Welcome all of you. I am Assistant Professor Kute Akshada from SND Engineering and Research Center Evla. Today's topic is Instrumentation of UV Visible Spectrophotometry. In this topic, we are seeing Introduction, Components of Spectrophotometry and Instrument Design. Introduction. Absorption spectrophotometry in the ultraviolet and visible region is considered to be one of the oldest physical methods for quantitative analysis and structural elucidation. First, wavelength. UV 200 to 400 nanometer, visible 400 to 800 nanometer. Instruments: photometer, spectrophotometer and colorimeter. First, photometer. Photometer is an instrument for measuring the intensity of light or the relative intensity of pair of lights. Also called an illuminometer, it utilizes filter to isolate a narrow wavelength region. Second, spectrophotometer. An instrument measure the ratio or function of 2 of the radiant power of 2 EM beams over a large wavelength region. It utilizes dispersing element instead of filters to scan large wavelength region. Next, colorimeter. Colorimeter is an instrument in which is used for measuring absorption in the visible region is generally called as colorimeter. Next point, components of UV visible spectrophotometer. Source of radiant energy, collimating system, monochromator system, sample holder or container to hold sample, detector system or collecting transmitter radiation, suitable amplifier or readout devices. These are the diagram of light emitting spectrophotometer. First, in this diagram, first is a light source and then collimating lens are used, dispersing the elements, sample container are used, detector and radiator. Source of radiant energy. Requirements of an ideal source. It should be stable and should not allow fluctuations. It should emit light of continuous spectrum of high and uniform intensity over the entire wavelength region in which it is used. It should provide incident light of sufficient intensity for the transmitted energy to be detected at the end of the optic path. It should not show fatigue on continued use. For visible radiation, tungsten halogen lamp. Its construction is similar to the household lamp. The bulb contains a filament of tungsten fixed in evacuate condition and then filled with inert gas. The filament can be heated up to the 3000 Kelvin. Beyond this, tungsten starts sublimating. It is used when polychromatic light is required. To prevent this, along with inert gas, some amount of halogen is introduced. Sublimated from of tungsten reacts with iodine to form tungsten iodine complex, which migrates back to the hot filament where it decomposes and tungsten gets deposited. Demerits. It emits the major portion of its radiant energy in near IR region of the spectrum. Source for UV radiation. Hydrogen discharge lamp. In hydrogen discharge lamp, pair of electrodes is enclosed in a glass tube. When current is passed through these electrodes, maintained at high voltage, discharge of electrons occurs which excites hydrogen molecules, which in turn cause emission of UV radiations in near UV region. They are stable and robust. Xenon discharge lamp. It possesses two tungsten electrodes separated by some distance. These are enclosed in a glass tube with quartz or fused silica and xenon gas is filled under pressure. An intense arc is formed between electrodes by applying high voltage. Demerits. The lamp, since operates at high voltage, become very hot during operation and hence needs thermal insulation. Mercury arc lamp. Collimating system. The radiation emitted by the source is collimated by lenses, mirrors and slits. Lenses. Materials used for the lenses must be transparent to the radiation being used. Ordinary silicate glass transmits between 350 to 3000 nanometer and it's suitable for visible and near IR region. Quartz or fused silica is used as a material for lenses to work below 300 nanometer. Next, mirrors. These are the used to reflect, focus or collimate light beams in spectrophotometer. To minimize the light loss, mirrors are aluminized on their front surfaces. Slits. Slit is an important device in resolving polychromatic radiation into monochromatic radiation. To achieve this, entrance slit and exit slit are used. The width of slit plays an important role in resolution of polychromatic radiation. First, monochromators. It is a device used to isolate the radiation of the desired wavelength from wavelength of the continuous spectra. Following types of monochromatic devices are used. First, filters. Second, prisms. Third, gratings. First, filters. Selection of filters is usually done on a compromise between the peak transmittance and band pass width. The former should be as high as possible and latter as narrow as possible. Absorption filters works by selective absorption of unwanted radiation and transmittance the radiation which is required. Example, glass and gelatin filters. These are the diagram of visible lights. Selection of absorption filter is done according to the following procedure. Draw a filter wheel. Write the color VIBGYOR in clockwise or anti-clockwise manner, omitting indigo. If solution to be analyzed is blue in color, a filter having a complementary color orange is used in the analysis. Similarly, we can select the required filter in colorimeter based upon the color of solution. An absorption glass filter is made up of solid sheet of glass that has been colored by pigments which is dissolved or dispersed in the glass. The color in the glass are produced by incorporating metal oxides like V, Cr, Mn, Fe, Ni, Co, Cu, etc. Gelatin filter is an example of absorption filter prepared by adding organic pigments. It tends to deteriorate with time and gets affected by the heat and the moisture. The color of dye gets bleached. Merits. Simple in construction, cheaper and selection of the filter is easy. Demerits. Less accurate, band pass is more. If we to measure at 400 nanometer, we get radiation from 370 to 430 nanometer. Hence, less accurate results are obtained. Thank you.